Hello and welcome to GCSE Chemical Changes with Mrs Castanera. We're on lesson 12, Electrolysis of Aqueous Solutions, and our example of NaCl, which is sodium chloride. Today's key words are ion, electrode, anode, cathode, electrolyte, molten, solution, and redox. So I'd like you to start by pausing the video to complete the knowledge check questions, remembering that question 7 is a higher tier question, so you may struggle with that if you're a foundation tier student, but you may also know it, so feel free to attempt that. Pause the video now, please. Okay, so let's go through those. Describe the role of cryolite. Well, it lowers the melting point of aluminium oxide, or you could have said aluminium ore. The product at the anode is the non-metal, in this case oxygen. You can say non-metal for the mark or oxygen. Why does the carbon anode require continuous replacement? Well, because it reacts with oxygen to form carbon dioxide. You don't need to use O2 and CO2. You can use the words oxygen and carbon dioxide. It was just tricky to fit them in. Why can carbon displace copper from the copper oxide? Well, because carbon is more reactive than copper. State the products of displacement of copper with carbon. Okay, so what they mean is actually displacement of copper oxide with carbon, but however they've written it, it's confusing. But the idea is that copper oxide added to carbon and heated turns into copper plus carbon dioxide. Again, I wrote CO2 because there wasn't enough space to write carbon dioxide. State the chemical formula of aluminium oxide, Al2O3. State where oxidation happens in electrolysis, well, at the anode. And name the product at the cathode, which is metal or aluminium in this case. Either of those is acceptable for the mark. Okay, so give yourself a mark out of 8 for that, please. And then we're going to move on. By the end of this lesson, you will be able to explain, in terms of the reactivity series, why some metals are extracted with carbon and others by electrolysis. You may already have some idea as to why this is. You will also be able to predict the products of the electrolysis of aqueous solutions containing a single ionic compound. Okay, so we're going to move on to electrolysis of aqueous solutions. Now, an aqueous solution is formed by dissolving the required compound in a solvent. Okay, so we'll make a note on this. Solvent plus solute turns into solution. In this case, the solvent is going to be water because in aqueous solution, aqueous means dissolved in water. So the ions then discharge, so the ions turn into atoms, when an aqueous solution is electrolyzed using inert electrodes. And it depends on the relative reactivity of the elements involved as to which ions discharge. Okay, so electrolysis favours the least reactive elements if there is more than one to choose from at an electrode. So what that means is that if there is a number of different products that could be produced, the least reactive one is going to be produced by the electrolysis. So at the negative electrode, also known as the cathode, which we should know, hydrogen is produced, okay, if the metal is more reactive than hydrogen. Okay, so there's a reactivity series which you have in your booklets, and it shows us the reactivity series. So I'm going to show you that now. So here we have hydrogen in our reactivity series. And so you can see that if the metal is more reactive than hydrogen, so above it, such as lead, tin, aluminium, magnesium, hydrogen will be produced. Another way of saying is that hydrogen is the least reactive choice. Okay, so it gains the electrons from the cathode over the more reactive metal, and that is not from, it is from. So to summarise, the cathode will produce metals or hydrogen, one of the two. We'll make a note about that. So the cathode produces metals or hydrogen. At the positive electrode, the anode, again you should know that the anode is the positive electrode, oxygen will be produced unless the solution contains halide ions, okay, in which case the halogen will be produced. So the halides are group 7, which is fluoride, chloride, bromide, iodide. Okay, so it's those group 7 elements. So the anode then will produce non-metals such as oxygen or group 7 atoms. So we're going to write a note about that. Okay, so as I said, the anode produces the non-metals, oxygen or group 7 atoms, and we're given some examples of these group 7 atoms as they would be written down in their formula. Okie dokie. So this happens because the aqueous solution water molecules, okay, they break down producing hydrogen ions H plus and hydroxide ions OH minus that are discharged. Okay, so we'll write an equation to show this. Now, this arrow that I'm drawing here means this is a reversible process, okay? It goes in both directions at the same time, continuously. And it forms hydrogen ions, which are positively charged, and hydroxide ions, or OH minus ions, which are negatively charged. So make sure you've got all those notes down before we move on. Okay, so move on to page 29, and we're looking at learning activity 1, which is the investigation of electrolysis of aqueous solutions using inert electrodes. Now again, this is an investigation that's practical. We can't do that with online lessons. So we'll talk a bit about it and watch a video, and then we'll move on. So we would have investigated the electrolysis of sodium chloride. So sodium chloride is an ionic compound with a giant lattice structure. Sodium chloride is salt, okay, and sodium chloride solution is brine. We're going to make a note about that. Okay, so sodium chloride is just table salt. Now, at room temperature, the ions are in fixed position and cannot move because they're solid. To free the ions, we could make the compound molten, but this requires a temperature of 1400 odd Celsius. A much simpler way is to dissolve the salt in the water to form sodium chloride solution, an aqueous solution, which we're calling the electrolyte. This aqueous solution is called brine, okay, which is simply salt water. So the water molecules will also be dissociating in this mixture, in this brine. Okay, so they're also going to dissociate and form hydrogen ions and hydroxide ions as well. Now there's a video about this, which I'd like to go and watch to learn more about this. We won't be doing the practical, but you will learn more about this process. So pause the video whilst you go watch the YouTube video, please. Okay, so hope you have a better understanding of how that process works in the electrolysis of brine. Now we're on page 30 here, and we're going to go down until we get to half equations at the electrodes. Now this is higher tier content. Okay, so if you are a foundation student, you're just going to move on to where in the video we get to the products of electrolysis. Okay, so higher tier students, just going to cover this please. So at the cathode we have 2 positive hydrogen ions, which are aqueous, they're dissolved in water. Add to that 2 electrons, because 2 negative charges will cancel out the 2 overall positive charges we have on the hydrogen, giving us diatomic hydrogen. At the anode we have 2 chloride ions, because it turns into Cl2, and 2 electrons. Now this is another way that people write half equations sometimes. So we would have written this as 2Cl minus, take away 2 electrons, not plus them on this side, but on this side, take them away because this is overall negatively charged. We need to remove the electrons from this and turn it into diatomic chlorine. This is a perfectly acceptable way to do it as well. They're both acceptable methods. Admittedly, this is a more common way of writing it, but don't worry if that doesn't make as much sense to you. Okay, so we're going to move on to products of electrolysis. So the electrolysis of sodium chloride solution, or aqueous sodium chloride, also known as brine, provides some very useful products. This is good, we like useful products. The chloride ions, the Cl- that are produced, they covalently bond together to form chlorine molecules Cl2, which is released as a gas. The hydrogen ions, H+, from the water molecules, they covalently bond to form hydrogen gas, H2. And then the remaining sodium ions, that's Na+, and hydroxide ions, OH-, form sodium hydroxide solution. Now, sodium hydroxide is NaOH, and solution means it's dissolved in water, so it is aqueous. And we can learn more about these products below. Okay, so chlorine, Cl2 as a gas, hydrogen, H2 as a gas, and then sodium hydroxide, NaOH, as an aqueous solution. These are the products, and then we have the uses here. So chlorine can be used as a bleach because it kills bacteria. It's an excellent disinfectant for the same reason. We also use it in UPVC, which is a window material, that white stuff that's like plastic around the edge of windows, and it's a polymer, which is used to make plastic window frames. Very useful. Hydrogen gas, H2. Well, incredibly, all your margarines and spreads, vegetable spreads that you have in your home in the fridge if you don't use butter, we use it to solidify vegetable oils, those oils you buy for cooking that are liquids. We add hydrogen, it turns it into those fats, those spreads that you use, such as clover and flora and batoli and all the rest of them, and that makes them spreadable fats instead of liquid fats at room temperature. Very useful property. Nobody wants to put oil on their bread, but everybody wants to spread margarine or spread on their bread. So sodium hydroxide is very useful in making soap. It reacts with something called long-chain fatty acids, which we'll learn more about later. It's also used as part of the pulping process when making paper. And again, when using bleach, it reacts with chlorine, okay, to form bleach. So you've got two products here that you require to make bleach. So a very useful process to produce bleach amongst other useful things. Okay, so take a few minutes to learn that. Pause the video whilst you learn the uses of each of these as well as the chemical symbols for each of these. Okay, so before we move on, we're going to cover a little bit about bonding because I think it's very useful and it will help you in the knowledge check in a minute. So go to your student notes page on page 32. So we're on page 32 on the student notes page. You can use paper if you like. So you're just going to write out a few brief bits of information explaining about the different types of bonding and when they occur. So first of all, a non-metal added to a non-metal will form a covalent bond. So make sure you copy these out as they come up. Next, a metal and a non-metal will form ionic bonds. And lastly, a metal added to another metal is going to form metallic bonding. Okay, so if you had a question, what product would you get if you added two things together? If those two things are a metal and a non-metal, for example, it's going to ionically bond together. So, for example, if you were asked about the type of bonding found in carbon dioxide, that's between carbon and oxygen atoms. Both of those are non-metals, so that forms a covalent bond because a non-metal bonded to another non-metal forms a covalent bond. So carbon dioxide is an example of two non-metals bonded together with a covalent bond. Now next we might think of something where there's a metal and a non-metal. So for example, aluminium oxide. Okay, aluminium is a metal and oxygen is a non-metal. Okay, and then that is going to form an ionic bond. Okay, so a metal and a non-metal forms an ionic bond. Lastly, you might be asked about two metals together. So for example, metallic bonding would occur between all the different atoms in iron, say, because iron is a metal, so the bonds between different atoms of iron is going to be a metallic bond. Okay, so it doesn't have to be different metals that are bonded together to make a metallic bond, it can be the same. So also this same principle applies to non-metals, so oxygen is O2, so a non-metal, the first non-metal can be oxygen, the second non-metal can be oxygen, giving you covalently bonded O2. Right, so now we have that summary written out and you should have a better understanding of the different types of bonding found between different types of atoms. We're going to move on to the knowledge check, which is way back on page 30. Okay, so here's the knowledge check. There are 8 questions. I'd like you to pause the video whilst you answer the questions, please. Okay, so let's go through those. The type of bonding in sodium chloride is ionic. The type of bonding in chlorine molecule is covalent. because it's two nonmetals. The type of bond in hydrogen molecule is covalent, again, because it's two nonmetals. Sodium was ionic because it's a metal and a non-metal. The type of current used in electrolysis is DC or direct current. Solvent plus solute turns into a solution. 2 uses of sodium hydroxide, Ne2 from soap, paper or bleach up to a maximum of 2. 2 uses of chlorine, Ne2 of bleach, disinfectant and UPVC up to a maximum of 2. 2 uses of hydrogen, bit of a trick question this one because we only gave you one. Margarine from arc, if you looked it up and had a look and found maybe rocket fuel or that it's used in the harbour process or for lots of other reasons, you can have those as well. So you have up to 2 marks for that as well. So if you've got something written down that's not on this list, that's fine. Check with your teacher before you give yourself a mark for it. So maximum marks here is 11. So give yourself a mark out of 11, please. So we're moving on to the application of knowledge questions on page 31. There are 4 questions here. First of all, state where the oxidation and reduction are happening in the electrolysis of brine or sodium chloride solution. Then question 2, state where the covalent bonds are formed and in which molecules in the electrolysis of sodium chloride or brine. Question 3, explain why hydrogen is produced at the cathode instead of the sodium metal. You're going to want to use your reactivity series to help you here. Here is a copy of the reactivity series in case you haven't got that on you right now. So you can pause the video or come back to this point in the video to help you answer that question. And question 4, explain why a membrane is usually used in the electrolyte between the anode and the cathode to separate the chlorine from mixing with the sodium hydroxide. There's quite a lot to that question. Okay, so pause the video whilst you answer those 4 questions and then we'll go through them together. Okay, so let's go through those. Question 1, state where the oxidation and reduction are happening in the electrolysis of sodium chloride solution as brine. Well, oxidation is occurring at the anode and reduction is occurring at the cathode. The chloride ions are being oxidised to form chlorine atoms, diatoms. You don't need to write this part, it's just so that you are aware of what is being oxidised and what's being reduced. And the hydrogen ions are being reduced at the cathode to form diatomic hydrogen. Again, you don't need to write that, it's just for your information. Part 2, state where covalent bonds are formed and in which molecules in the electrolysis of sodium chloride or brine. Well, we've already explained before that Cl2 is formed at the anode and that H2 is formed at the cathode. And then I've drawn a diagram to show these. So Cl2 is Cl with a line to Cl2 and that line represents a covalent bond. And the H is joined by a line to the other H, the hydrogens, and again that's a covalent bond. Okay. Question 3. Explain why hydrogen is produced at the cathode instead of a sodium metal and use the reactivity series to help you. Well, sodium, the metal, is more reactive than hydrogen, so that's your first mark, so sodium is more reactive than hydrogen. And then electrolysis favours the least reactive elements for a second mark. Okay, so electrolysis will produce the less reactive metal, or less reactive element, in fact. Okay, and question 4. This is quite a long one. Explain why a membrane is used in the electrolyte between the anode and the cathode to separate chlorine from mixing with the sodium hydroxide. Okay, so 2-part answer here. You've got to separate the chloride and hydrogen ions so they don't form hydrochloric acid. Okay, so chlorine is forming and gassing off at one end and hydrogen at the other end. You don't want those two to mix because then you get hydrochloric acid. Okay, so you get a mark if you've mentioned hydrochloric acid. Okay, there's an equation to show this. Cl minus plus H plus turns to HCl. If you've written that out, you can have a mark. It's another way of saying about the forming hydrochloric acid. Okay, then if you're making less chlorine, that means the whole process is less efficient, okay, and less profitable. So anything about why it's bad to make less chlorine. Okay, so I'm going to give you a maximum of 3 marks here. Okay, 2 marks question 3 and 2 marks question 1, that's 1 for each, and 2 marks for question 2. So 2 marks for each of the questions apart from part 4, which has 3. So let's mark out 9, please. Okay, and that is the end of our lesson. If you have any questions, please ask your teacher or email me. We're very happy to help. Thank you very much.